Hello everyone. In method validation today we will learn about matrix effect, recovery, dilution integrity and reinjection reproducibility. So first of all we will learn about matrix effect. So what is matrix effect? So matrix effect is a direct or indirect alteration or interference in response due to the presence of unintended analytes or other interfering substances in the sample, that is plasma, blood or serum. So if we say in the simple word like matrix effect, that means effect of matrix on our method, that means on the response of the method. Matrix means anything related to plasma, blood or serum. So effect of this matrix on response of our analyte. Now, there may be suppression or enhancement of ionization of analytes, resulting in increase or decrease in analyte response due to matrix effect. So, if we say that because of matrix effect, there may be suppression or enhancement of ions of analytes, that means there will be increase or decrease in the response of our drug. That means due to matrix effect, there may be increase or decrease in our response of analyte. Now, what are the factors that affect the matrix effect? That means because of which factor there will be effect of matrix on our response. So there are certain factors such as matrix components. As I told you that in matrix, that means plasma or blood, there are many other substances that is available in the matrix. Another thing is residue released from the material used during extraction process. That means during extraction procedure, we use methanol, acetonitrile, or we may use buffer, or we may use formic acid, or any other thing. So, effect of this thing may release some of the residues that also affect the extraction process, and there will be matrix effect. Another factor is interconversion during extraction. That means maybe there will be interconversion between drug and metabolites. Next point is purity and assay of reference or working standards. Stability of analyte during extraction, reagents or mobile phase, ion source, or and another point is mass and charge of the analyte. So all of these factors are that affect the matrix effect. Matrix effect has been regarded as the most important issue in the LCMS methods because it can adversely affect the accuracy, precision, and sensitivity of the analytical data and hence cause irreproducible result. Now I will explain how exactly matrix effect takes place. Here, how matrix effect takes place in the ESI. ESI means electrospray ionization. Now there are two cases. One is standard solvent and another is sample extract. So this sample extract means this is with matrix, that means our plasma, and this is standard solvent. This is without matrix. So this case is without matrix and this is with matrix. So you can identify between two that what exactly matrix effect. Now this is for example this is the solvent and there are some this is the A means analyte here. These are the analytes and these are some hydrogen bond. Now in mass there will be evaporation and that uh, there will be protonation of this analyte with hydrogen. So this analyte will be attached with this and based on this here this is 5 into A plus H. That means there are 5 A plus H bond. So resulting in this peak. Okay. In the opposite case, if we take the sample extract, there is availability of analyte here, but apart from that, there are some substance of matrix available in the sample matrix that we call as some another compounds. So these are the matrix components as well as this is analyte also. So here in this case there will be competition for the protons in this because some of the matrix component will attach with the proton. here you can see that only one analyte attached with the proton, while another 4 matrix component attached with the proton. So that means resulting in here only one A plus H bond and 4 M plus H bond. Here compared to here this is 5, while here it is only 1. So you can see that the response between here and here. So this is resulting in the lesser response. So this is the decrease in the response, you can say. So this is mainly matrix effect, that it will be decrease our peak area and it will decrease our peak height also. So you can say that single intensity is very decreased compared to here. So this is the basic idea how matrix effect occur. Now, what are the points that how we can minimize the matrix effect? So there are some points like more selective extraction procedure. Sometimes we can see that in if we change the method or if we change any step in the method, there will be decrease in the matrix effect. Then changing buffer and extraction solvent. Sometimes extraction solvent also plays role in matrix effect and recover matrix effect. Then use of table label internal standard. Because of this internal standard also there will be decrease in the matrix effect. Now, how to conduct the matrix effect experiment? So, to conduct the matrix effect experiment, we have to take 8 different matrix slots, from which 6 will be normal, 1 will be hemolyzed and 1 will be lipemic. As you see that this is the matrix effect experiment, so we are analyzing the effect of matrix on our quantification of analyte. So we are taking 6 normal lots. Why we are taking 6 normal lot? Because there may be difference in the characteristic of the plasma sample of different person. So we are taking 6 normal lot. We are also taking 1 hemolyzed lot because maybe during sampling there may be some hemolyzed plasma we get, and also we get lipemic plasma. So by this way we can also analyze the effect of hemolyzed plasma and lipemic plasma on the quantification of our analyte. Then what we will do? We will prepare set 1 and set 2 at low QC and high QC level. Now you may be confused that what is set 1 and set 2. So set 1 is the standard solution, that is without matrix. As I shown you in the previous slide, that standard solvent or standard solvent. So this is the standard solvent that is without matrix. And another set 2 is the spiked post extraction. Set 2 means what? We have to analyze the blank plasma and we have to spike our low QC and high QC sample post extraction. So this is with matrix. And now how we can determine that? So we can determine by that matrix factor, that peak area in presence of matrix divided by peak area in absence of matrix. So after we prepare all of this sample, we have to inject that in LCMS, and then we will measure the peak area in the LCMS, and we will use this equation to determine the matrix factor, that peak area in presence of matrix and in absence of matrix. Now if we use this equation, we can see that it may be more than 1, it may be less than 1, or it may be 1. So now how to determine this thing? So if the matrix factor is more than 1, that means there is ion enhancement. So this will be resulting in increase in the drug response. And if it is less than 1, then there will be ion suppression. That means it will be decrease in our response. And if we get it 1, that means no matrix effect. Now matrix effect should be calculated for analyte and internal standard both. So we have to calculate matrix factor for both analyte and internal standard. And we have to calculate then IS normalized matrix factor. So what is IS normalized matrix factor? So it is the matrix factor of analyte divided by matrix factor of internal standard. And then finally, what is acceptance criteria for this matrix effect experiment? So CV of IS normalized matrix factor for all lots should not be greater than 15%. So we have to take the IS normalized factor for all lots, all 8 lots, and the CV of all lots should not be greater than 15%. So this is all about the matrix factor and matrix effect. Now we will learn about the recovery. What is recovery? So definition of recovery is that extraction efficiency of an analytical process reported as a percentage of known amount of analyte carried through sample extraction process. So in simple word, if we say that recovery, what is recovery? So recovery means the name itself, recover. How much we can recover from our method of extraction? How much analyte we can recover from our extraction method? So moving to the next point, recovery need not to be 100%, but it should be consistent and reproducible for analyte and internal standard. So from any of our method, maybe it may be not be 100%, whatever the analyte we spike in our standard solvent. After extraction, we may not get all of them, but it should be reproducible and consistent at all time. Now, how to conduct this recovery experiment? So, recovery experiment should be determined at three level, that is low QC, mid QC and high QC. So here, first of all, we have to prepare the 6 sample of low QC, that is extracted sample, that is as per our extraction procedure, and another 6 sample of low QC, that is post extracted. That means first of all we have to process our blank matrix, and then when we get the final extract, we have to post spike it by our low QC serial solution. So 6 sample of this extracted and 6 sample of post extracted sample, and in the same way as of above, we have to prepare mid QC 6 sample and high QC 6 sample. So 6 samples from each of low QC, high QC and mid QC as extracted, and 6 sample of low QC, mid QC and high QC post extracted. And this is the formula to calculate the percentage recovery. So percentage recovery is equal to area of extracted samples divided by area of post extracted sample into 100. So this is the formula. Now, what is the acceptance criteria for a recovery experiment? So percentage CV of calculated percentage recovery should not be more than 15% at each QC level as well as across all QC level. That means we see that previously that we take 6 sample of low QC, mid QC and high QC. So and we will determine the recovery. So there will be 6, we will get recovery for 6 low QC sample, 6 mid QC sample and 6 high QC sample. So percentage CV should not be more than 50% at each QC level. So there will be 6 sample of low QC. So the precision should be less than 15%. As well as we have to also calculate the percentage CV across all level of QC. That means low QC, mid QC and high QC. So this CV also should not be more than 15%. So this is all about recovery. Now our next experiment is dilution integrity. Why we require this experiment, dilution integrity? Because we see that previously that we determine the calibration range as per our Cmax of the drug. So, for example, if we determine our range from 0.5 nanogram to 100 nanogram, so 100 nanogram is our upper limit of quantification. Now, during study, it may happen that some of the subject sample will go above this 100 nanogram, that is our upper limit of quantification. Sometimes we get the response of 105, 110 or maybe 115, 20, 130. So in this case, we cannot say that these samples have proper accuracy. Why? Because our range is validated in the range of only 0.5 to 100 nanogram. Our range is not validated above this level. So we cannot say that this sample is accurate. For this purpose, we carry out dilution integrity experiment. So as now if we read this experiment is carried out to assess the ability of the method to quantify the analyte and yield accurate and precise result after sample dilution. So, uh, as I tell you previously that if we get we will get some sample out of our calibration range. So for this, what we will do? We will dilute this sample. For example, if we get 150 nanogram per ml for some of the sample, then what we will do? We will dilute this sample and we will let this sample to be in our range. So if we dilute this samples, let's say for example 150 by half, then it will become into 75. So 75 is in our range. That means it is in our validated range. So that means we can rely on this result of the sample. So this is the main purpose of this experiment, that we will dilute some of the sample and we will measure accuracy and precision of our method. So how to conduct this experiment? First of all, prepare 6 QC, that is dilution QC, we will tell it as a dilution QC, with concentration higher than the ULOQ of the original concentration by n times. Here n is equal to at least 2. I will explain this by a simple example. Let's say for example, if our ULOQ is 100 nanogram per ml. Okay. So what we will do? We will prepare dilution QC as 200 nanogram per ml. That is n is equal to 2. So this is 2 times of our original concentration of ULOQ. So now I prepare dilution QC of 200 nanogram per ml. So now if I want to prove dilution factor, dF is equal to dilution factor as a 4, that means I will divide it by 4. And now if we see that for example aliquot volume is 200 microliter, that is aliquot volume, that is the first step of our extraction process. So for this, now what I will do, now my dilution factor is 4 and my dilution QC concentration is 200 nanogram per ml. So I will use that equation, that N1 V1 is equal to N2 V2. Okay. So here my N2 is 50 microliter, because if I divide 200 by 4, that means 50 microliter. So my N2 is 50, my V2 is 200 microliter, and my N1 is 200 nanogram per ml. So V1 is equal to V1 I will get will be 50 microliter. So I will take 50 microliter from this dilution QC that I have prepared, 50 microliter from this dilution QC, and another 150 microliter of blank plasma. So this blank plasma have nothing in that. That means this is blank, this is without analyte. And this 50 microliter of dilution QC, which contains 200 nanogram per ml of drug. That means this sample will be resulted in 50 nanogram, because my dilution factor is 4. So if I divide 200 by 4, it will come into 50 nanogram per ml. And as I discussed previously, that our ULOQ, that means our upper limit of quantification, is 100 nanogram. So now if we prepare this sample will come in the range of around 50 nanogram per ml. So this will become in our range. So when I conduct dilution integrity experiment, I will prepare 6 dilution QC like this, and from this 6 dilution QC, I will prepare 6 samples. That means 6 extraction sample I will prepare from dilution QC by applying the dilution factor 4. And then I will inject this all 6 dilution QC in with calibration curve. Now, what is acceptance criteria for this dilution integrity experiment? So, accuracy and precision should be within 15%. That means if we inject 6 QC and as per accuracy and precision criteria, that it should be less than 15%. I mean, accuracy should be within 15% and precision should be less than 15%. So, this is all about dilution integrity experiment. Now, our next experiment is reinjection reproducibility. So as the name suggests, reinjection and reproducibility. If I reinject any sample, I will get reproducible result. That is called reinjection reproducibility. Now, what is the main reason to conduct this experiment? To assess ability of the method to quantify analyte accurately and precisely upon reinjection. Now, during routine analysis of our sample, there may be some case that instrument error occur, that LCMS stoppage due to nitrogen error or any other thing, there will be stoppage. So in this case, we have to do, we have to reinject all our sample or some of our sample. So to determine that if we reinject our sample, we can accurately and precisely quantify the analyte of interest or no. For this purpose, we do reinjection reproducibility experiment. So how to do that? So inject one of the accepted accuracy and precision batch. What we will do here, as we discussed previously about accuracy and precision experiment, that we conduct 3 ACPR batches. So we will take any of them, any of this ACPR batch, and we will, if it is accepted as per our acceptance criteria, then we will reinject whole ACPR batch again in the LCMS. Okay, and we will determine again the result of this reinjected sample, and acceptance criteria as per our ACPR, that for QC, for low QC, mid QC, high QC, it should be accuracy should be within plus minus 15%. For LLOQ QC, it should be within plus minus 20%. And calibration curve also, and blank and zero sample. For calibration curve, it should be 15 within plus minus 15%, except LLOQ. For LLOQ, it should be plus minus 20%. And overall QC, at least 67% of QC should pass the acceptance criteria, and at least 50% at each level, as well as from calibration standard also, at least 75% of calibration standards should pass. So this is all about reinjection reproducibility. So in today's presentation, we learned about matrix effect, that is effect of matrix on quantification of our method. Then we learn about recovery. Recovery means how much percentage of analyte we can recover from our method. Another thing we learn, that dilution integrity, that if we dilute our sample, still our method is accurate and precise. And the last thing we learn, that reinjection reproducibility, that if we reinject our sample, still our method is accurate and precise. So this is all about this experiment, and this is the end of today's lecture. In the next part, hopefully we will learn about stability studies. So thank you so much, all of you.